You're welcome. This is elementary set theory and number system. So we're going to start with chapter one, and basically what we'll be considering everything you can see on the screen there. I want to make this 5 minutes video, because it is my expectation that you know all of what we're going to be treating in this video today. Okay. So we have definition of sets and what a set has to, definition of a set, elements, and structure of a set, like what we call Rooster method. Building, how you build sets, right? If you want to describe them, the set builder notation. You can pause the screen and read them and know these definitions, or recall these definitions, because it is my expectation that you know them already from your secondary school days. Okay. And we have more definitions: find set, infinite set, empty set, subsets, things definitions that has to do with set theory. Okay. Again, you can pause the video and go through the definitions, recall them. There are more definitions here. Okay. So let's go straight to the examples. Like I said, you can pause the video and get the definitions straight. This diagram here basically shows you how the numbers. Okay, so let me go back. Before now, we had considered numbers, the different kind of numbers, and how you can see them pictorially. And this gives you the pictorial view of them. You have the complex numbers, after which in the complex numbers, we have the imaginary part of the complex numbers and the real part, right? So under the real part, we have the irrational and the rational. And under the rational, we have the fractions, integers, okay, the negative integers and whole numbers. And under whole numbers, we have the zero and the positive integers, or the natural numbers, okay? So this you need to know and be able to, if you're asked to draw or tell us how these numbers look, you should be able to list elements in them, like you should know complex numbers take this form and the likes, okay? Let's move forward. So we have the first example here, exercise, which I'm expecting you to solve. I can solve the first one for you. It says, using the Rooster method, describe the following set. So I expect you to know what the Rooster method is. Simply go back and read the definition. So for the Rooster method, we're told to, using the Rooster method, describe the following set. So for number one, simply A will be equal to what now? It's simply saying that A is X, so the X is a month in the year. So you simply do this. The answer will be equal to the first month of the year is going to be January, right? January, February, March. So you write all of the months until you get to December, right? And then you close the bracket, okay? So that's the solution to the first one there. So I expect you to solve this. You're going to bring the solution during our first class, okay? Next to it is the exercise, and exercise 2, which says use the set builder notation to describe the following. So the set builder notation is basically you're going to write this in form of an equation like you have here, right? So how do you do that? So simply A would now be equal to, for number one, A will be equal to X such that X is a what? Vowel, right? Vowel in the English alphabet, okay? And then you close the bracket, alphabet. Sorry, I'm writing in a hurry. Okay, so this will be your answer, okay? So I expect you to solve these exercises and have it submitted during our next class. I will let us know when the class will be. Okay, so we have some examples here. I'm sure you remember this one. So we have a universal set that consists of all of these entries. We have subsets, right? Subsets A, B, and C. So this is A, this is B, right? This is B here. B letter, capital letter B is missing there. So there's B, this is B equal to this here. and then C. Okay, so the first one says we should find A union B. Basically, A union B will be the collection of the elements in A and B combined as one, right? So you should be able to do A union C, A union B intersection C. I think A minus B might be the one that you might find difficult. Well, basically, this is saying that all elements of all elements of A that are not in B. Okay, so let's look at this. Elements of A, this is A, and they are not in B, this is B. Minus 5 is in A. Is minus 5 in B? No, so minus 5 will be in this arc set. Minus 4 is in A. Is minus 4 in B? No, so minus 4 will be one of the elements. And you keep checking till you find them. So if you go to the next slide, you see that each of them has been solved for you. In fact, you can see here, see the difference, A minus B. And you can see the answer here. Okay, so you can go through by pausing and just checking the solutions one after the other. I'm sure you know what B complement is. B complement means all the elements here all the elements that are not in B but are in the universal set. Okay, so you can check that and double check your solutions. Okay, you can also do this. This one has to do with the direct product, X cross Y. Okay, and Y cross X. You can see the solutions here. Well, during the class, we can talk about it during the physical class. So I expect you to be able to recall all of this because it's expected that you've done this in secondary school. So more examples and their solutions. Thank you.